Hey, good morning, everyone. So if you missed the review from last class, this video is a quick rundown of what we covered. So when you're working on your portfolio, this is kind of your tool to support you and trigger your thinking if you need it. All right, so when we look in at the first problem, graphing lines, remember when I'm asking for the slope, I'm just asking how far up, how far over, or how far down, how far over. So if I take a look at our graph here and I look at my 2 points and I zoom in, if I go from here to here, I'm going from 3 up to 13. You can count it out. That's 10 spaces. And then I'm going from 4 to 9. That's 5 spaces over. So when I'm talking about the slope for this one, I should have gotten 10 over 5. But you can always reduce that down to 2 over 1 or just 2. So any of those would be acceptable slopes. Now remember, we also have two types of linear equation formats. We have point slope and we have slope intercept. Well, if I'm doing point slope and I'm looking at this graph, remember that's of the format y minus something equals my slope, which we said was 10 over 5 or 2 over 1 times x minus something. The y minus and the x minus, notice I have an x value of 4, a y value of 3, so I could put in 3 and 4, and there I have it. Or instead of using 3 and 4, notice how I have this other point, 9, 13. I could have put in 13 and I could have put in 9, and once again, I get a proper equation. So that's point slope. If I'm thinking about slope intercept, well, now that I have my line, I can see that the y-intercept is down at -5. So I could type in y equals 10 over 5x minus 5, and once again, I get the same exact line. So point slope uses a point, slope intercept, I specifically have to find my y-intercept. All right, so with that said, that would have been my answer to problem 2. Problem 3, I'm saying Mrs. Hamby's going to buy ice cream, and she's buying baby creamies, and she's buying large creamies. So when it's saying she's getting baby creamies for $2, large creamies for $5, but her total bill is 80, all this is asking me to do is figure out what are some combinations of those I could have found so that I'm getting an $80 bill. So for example, I could have said just 40 baby cones and no large, because 40 baby at $2 a piece is 80. I could also do something like maybe I got all large, so I could do 0 and 16. Now, I guess the harder option is how do I find some other combination? Well, maybe I got 10 baby cones, so that would be $20. That would leave me 60 left over. Well, at $5 a piece, that would make room for 12 large. All right. So if I wanted to, for writing the equation, I could throw this table on the graph, and then I could try to find the line that goes through it. Or I can say, just from the table and using what I learned about point slope format up here, I could say, well, in this case, if I'm thinking about my slope, it goes up 12, but down 30. So maybe I say a slope of 12 over -30. Or in this case, it goes up 4, down 10. But notice how if I divide 12 and 30 by 3, I get this exact same thing. So they're actually equivalent. And I could even reduce further and do that. All of those would be possible slopes. So when I'm writing the equation, once again, I can do y minus equals, maybe I just use my most reduced version, x minus something. Well, notice how this is a point, this is a point, and this is a point. And I can think of this as my x. I can think of this as my y. Well, I'm going to take that point 10, 12, and there's my equation, all done. All right. And once again, if you wanted to, you could always throw your table on the graph, and you could make sure that your equation works. All right. Beyond lines, remember we have parabolas, and we've got multiple formats for parabolas. So when I look at this first one, because I'm giving you x-intercepts, you should really think about that being factored form. All right, so if I go to my graph here, all my points are already plotted. Sorry, this should say problem 3. So now when I zoom in, I can see, oh, I have an x-intercept at -7 and a x-intercept at 2. So if I type in here, I know factored format, my a value I can assume is 1, and then it's going to be x minus something times x minus something. Well, because I have -7 and 2, I'm going to have x minus -7, x minus 2. Now it goes through my x-intercepts, but if I zoom out, it's definitely not going through this point here. Remember, a tool is if I make this a negative, I flip things upside down, still not working, so I have to say, oh, what should this number be? Maybe I make it a 4. That stretched way too much. And so maybe I drop back down to a 2. And sure enough, now that I make my a value a -2, it's upside down and it's stretched perfectly. So this would be my equation in factored form because I know my x-intercepts. Problem 2 is saying, what if you converted to standard form? So what we tackled in class was we said, well, if this was my equation, I can distribute my -2, and that's where that -2x minus 14 came from. And then, in order to multiply these two things, -2 times x is -2x squared, -2x times -2 is 4x, -14 times x, and then -14 times -2. Then these two things both just have an x, and so we can combine them into this. And here's my standard form. All right. So with that said, here, I'll type it in just so it's useful for you all later. Oops. Now for problem 3, notice how it's giving you a vertex. So just like factored form uses the x-intercepts, we have a vertex form that uses our vertex. So if I go in, turn off this old stuff and turn on the new one, I can see, sure enough, that this must be my vertex. And I know it's going to be of the form some a value. For now, I'm just using 1 as a placeholder. X minus something plus something. Well, the x minus something, my vertex is at -3, +8. So I'll get x minus -3 and a +8. And you can see, sure enough, here's my vertex. But just like before, it's not stretched enough. So if I update it to a 2, it turns out it stretches perfectly. All right. And so that's your quick rundown of how we graph parabolas. All right. Once we're beyond that, solving for points of intersection is kind of that piece that's really difficult. And it's just been a really long time. So in this case, I'm saying specifically use substitution. And if I look at my two equations, the reason we can use substitution is notice how one of them is equal to a variable. So if I throw this down on paper, you can see that what we did in class was we said because y equals something, 5x minus 11 in this case, and there's a y in the other equation, we can take that other equation and rewrite it exactly except for where y used to be. Now that's replaced by 5x minus 11. And then we distributed our 6, we combined like terms, and then we added to both sides and divided to end up with x equals 2. And now that we know x is equal to 2, we plugged into our simpler equation and said, oh, when all is said and done, it comes out to y equals -1. So the point of intersection must be at 2, -1. And when the problem says check your graph, you can see, sure enough, that those two lines intersect at 2, -1. All right. Problem 2, I'm just going to preview this and say the graph shows us it intercepts at or intersects at 3, 2. So if I look at problem 2, it's saying use elimination, and notice how x's are stacked, y's are stacked, equals are stacked, and numbers are stacked. That's your clue that elimination is going to be the proper approach. So if we go back to paper here, once again, we took a look here and said if we add these two equations together, there's no way that x and y are going to eliminate, because adding these two, that's not going to be 0, and adding these two, that's not going to be 0. So we said, what would this thing have to be to make that work? So we said, if we wanted to eliminate x, these would both have to be 14s. So we multiplied by 7, and we got this. But we multiplied by -2 here because it gave us a positive 14x, and that's why they eliminate. They're opposite signs when we add. So when we added our two equations together, x is eliminated. We were left with a 26y and a 52, and we got y equals 2. Elimination's harder in the sense that I have to take this 2 and plug into one of my two equations, but it doesn't work out quite as nice as substitution. I actually have to do some solving after I substitute. But it comes out to x equals 3, and just like we saw on the graph, our point of intersection is at 3, 2. All right. So problem 3 is asking us to find the x-intercepts of a parabola. So, turn this on. Oops, made an error. So if you take a look, we're going to find out that our x-intercepts happen at -2 and 5. But the problem does say solve for them. So let's take a look at how we did that. Only if I can use a computer correctly. All right. Cool. So looking at problem 3, we said, okay, you have your parabola. The x-intercepts happen when y is 0. And then we looked at all of these terms and said, oh, notice how they can all be divided by 3. Well, when we do that, we're left with this. So remember, we're making our box, and we're trying to decide what are the factors of -10 that add up to -3. And we found out that 2 and -5, 2 times -5 is -10, but if I add them, I get -3. So x times x is x squared, 2 times -5 is -10, -5 times x, and then 2 times x. And sure enough, these combine, leaving us with this factored form. But remember, I'm looking for x values that make this thing 0. So if x was -2, this would be 0. And if x was 5, this would be 0. So those are my two x-intercepts, -2, 0, and 5, 0, just like we saw on the graph. All right. And lastly, taking a look at problem 4, I'm asking you to use the equal values method to solve for a point of intersection between a line and a parabola. So equal values method says because this equals y and this equals y, I can say when do they equal each other? But because this is a parabola, I need my whole equation to be equal to 0. So we said, well, let's make this side without the x squared 0. So we added 2x to both sides, and we subtracted 3 from both sides. After we did that, we got to here, and then saw we could make our life easier by dividing everything by 2, and now we're here. Well, this is a nice problem because 5 only has one set of factors, 1 and 5. And so when we factored, we said it's got to be x and x plus 1, x plus 5, and sure enough, our box works out. But just like when we were finding x-intercepts, because this equals 0, just make sure you take a look and say, oh, in this case, -5 and -1 would be the things that make this 0. And then we took one of our equations, the linear equation, because it's easier to use, and we said, what if x is -5? What if x is -1? And when we solved, these were the two x-intercept, or the 2 points of intersection that we came up with. All right. And Lastly, if we take a look at this graph here, you can see, sure enough, that we have one point of intersection at negative 513 and one at negative 1, 5. All right, we're almost done here. The last thing was producing our line of best fit. So when we're looking at the graph, we compared hours watching Netflix to the electric bill. And for us, because as hours goes up, the bill goes up, this one is a positive correlation. And just for the sake of being brief, um, positive because the more hours you watch, the more money on your electric bill. Producing a line of best fit, remember we have this tool because our data is labeled X1, Y1. We can say Y1 is, that's squiggly, MX1 plus B, creates a line of best fit for me. And notice, it seems to match that data pretty well. And notice how it's giving me an M value and a B value. So remember, it's giving me my slope, and it's giving me a y-intercept. So once I type it in, you'll see that this equation lines right up with that line of best fit. So what this is telling me is it's about 42 cents an hour for Netflix, but just for being an electric customer, I already owe the electric company about $4.63. So now we have our equation. Just remember, this isn't our equation. This is just telling Desmos to make us a line of best fit. I have to actually put it into equation format. All right. Problem 3 is saying, if we watch 30 hours of Netflix, because we know our x-axis stands for hours, we could always do, make it nicer, we could always do this. And then when we solve that, it's going to give us the answer we're looking for. An alternative is, because 30 hours is an x value, I could type in x equals 30. Notice how on my graph, it produces this vertical line that tells me that at 30 hours of watching, it's going to be about $17.37. And if you calculated this out, you would actually get the same exact thing. Because it's $17.37 and a half cents, you could really round up, or you could just leave it as 17.37. All right. This one is saying, oh, if this is the bill, how many hours? Well, because the bill is a y value, my alternative is I can type in y equals 2523. I'll turn off my x value here. And if you zoom out, you'll see here's my vertical line at $25.23. It intersects my curve and says at about 48.5 hours. All right, and that's it. That's the rundown of all the big ideas from the course. So as you're cranking out your portfolio, take a look at this if you need some review, and let me know if you have questions. But I look forward to conferencing with you later this week.